Good morning, everybody. So sorry, Peter, there's going to be yet another shower for your book. This one is expected to come in this December of this year and to be caused by Comet 46P Wirtanen. So I'm going to first introduce the comet itself and talk a little bit about the dynamics of the comet and the stream and provide you with the details of the forecast. So Wirtanen is a Jupiter family comet discovered in 1948 at Lick Observatory in California. And you probably know it better because it was the initial target of the Rosetta mission until the whole mission was delayed. And then they refocused on Chomov-Gerasimenko. It's a small comet, like a 1.4 kilometers in diameter for the nucleus. Yet it's active enough so that you can clearly see it in the sky and take pictures of it. So as mentioned, this is a Jupiter family comet. So it goes very close to the Jupiter orbit here in yellow, and then it's going to come very close to the Earth here in blue. So potentially, just by looking at the orbit of the comet, anyone might think that this would be the parent body of a shower, except that it comes outside the orbit of the comet, and by default, when the dust is ejected, it's going to go outside the orbit of the comet. So that's why up to now, there has never been any expected shower from this very comet. And Égal conducted some simulations, backward integration simulations of the comet, and you can see that it's quite stable until roughly 1830. So that means that we're quite confident of the orbit of the comet until the early 19th century, which is good news for us because the orbit of the comet is the starting point of all those simulations. And if the orbit of the comet is wrong, then any following conclusion might be completely outdated. So we simulated the ejection and the evolution of the stream in the whole solar system for at least a half a dozen perihelion passages. And I'm going to focus here on the trail ejected in during the perihelion passage of 1974. So this is going to be an animation showing you the 3D plot of the orbit of the Earth, Jupiter. Jupiter is here, and the comet, and you will see 10,000 particles ejected from the comet and going to the solar system. So that's a 3D view. That's a 2D view. So you have X and Y. Again, Earth, comet, and Jupiter here. And this is the orbital elements, semi-metric axis versus eccentricity, and perihelion distance versus inclination. So at the beginning of the simulation, the whole dust is still very close to the comet. So you can't really see it here. Okay. And now, as you have noticed, there was a close encounter with Jupiter. So now you can clearly see the comet here. The dust is clearly different at different symmetric axis and eccentricity. Sorry. The very close encounter with some of the dust makes it to be ejected out of the plane. And basically, you have a well separation between the comet, the dust that is close to the comet, and anything that came too close to Jupiter. You can also see it here. Another thing you can see is that the semi-metric axis of the dust is generally shorter than that of the comet. It means that the period is going to be shorter as well. Basically, the dust is going to revolve around the sun quicker than the comet itself. So anything that is trailing the nucleus here eventually will go in front of the nucleus. Takes some time, and that's what we see now. Oops, it was supposed to stop in 2023. Okay, anyway. Well, that's a good occasion to show you how complicated it is, if ever you haven't seen anything like that before. Okay, will I be able to stop it? Okay, 2024, good enough. Again, the point is the trail is now leading the comets. In 2023, the comet's going to be here and the trail is going to come close to the Earth. And I'm showing you this trail, obviously, because that's the one that the Earth will encounter this year. So this is a graph similar to what David Asher produced for the Leonids. So you have the trajectory of the Earth here, and that's the heart of the trail ejected in 1974. So those calculations are by Mikiya Sato. And when you look at the particles that are not in the core of the trail, that's why I represent here, you can see that there are some particles that will make it to the Earth. That means that we will not hit the very center of the trail, but what's on the edge of the trail. That also means that if you consider the location of the center of the trail and you project it on the Earth, you have a timing that is completely different from if you consider these particles here. Doing so, we found another possible encounter in 27, but you can see that the density of the particles is much less back in the days. And Oyan had a look at the size distribution, and presumably those are small particles, less than 1 millimeter. Now, putting numbers in there, I won't go through all the details, just to point out that it's going to be December the 12th. So it's going to be right into the Geminids. So the good news is that even if this shower does not show up, you will be outside looking at the Geminids. The entry velocity is going to be slow, 10 kilometers per second, and the declination is minus 38. So it's a southern shower. ZHR is very uncertain, as usual, because we've never seen this shower before. Again, this shower by Mikiya, the timing by Mikiya Sato is off clearly because of the reason I explained you. And Kwanziye, I quote him here, the timing can be off by 8 hours by using different dust size distribution. So it's a good news. It means that if you observe it and if you are able to estimate the magnitude of the meteors, then we can have a size frequency distribution of the comet. And then we can pinpoint what happened in 1974 for the comet itself. Now, how does this translate into practical observation? Again, the radiance is in the southern hemisphere, and the subradiant point is south of Australia here. So the best location would be northern and eastern Australia. So maybe the IMO can organize a trip there. Just kidding. Sorry. New Zealand is also a nice place. Southeast Asia. So I'm not sure how many IMO members are there, but I'm sure there are lots of meteor enthusiasts. Anyway. Okay, so the bottom line is there will be a new meteor shower coming this December. Again, it's going to be during the Geminids, so please do observe anyway. There are lots of similarities with the new shower caused in 2021 by Comet Finley. And again, your observation will help constrain the cometry physics. Thank you. Thank you.